Steph, welcome along to the podcast. It's great to have you with us.
Thanks for having me, Jason.
We are talking today about your latest column for Maxim, Pandora's Box, the perils of gene technology. Now, this comes off the back of National's announcement that they want to open up gene technology, I guess, in New Zealand, to let it out of the box, to use your metaphor. Tell us a little bit about that. What are they proposing? What are they hoping to do? What are their reasons for it? Give us the lowdown.
Yeah, so just over a week ago, National announced that they were going to go forward with one of their campaign promises, which was to overhaul the gene restrictions in New Zealand. So they're going to allow some of that technology to be used in ways that the legislation prevented in the past. The documents that they've released about it haven't spelled out all of the details, but they've basically said that the new legislation will be modeled on existing legislation in Australia, and this will involve relaxing some of the restrictions as well as creating a regulator who will kind of oversee managing the risks and the ethics of gene technology use in New Zealand.
So sort of like a broad brushstrokes, no actual legislation. Is there any policy documents around it or anything to give us a little bit of a clue?
They did put out a policy document which you can find on their website, but it's still short on the details. I would say it's more of a advertisement or a sell of why we should be pro these changes. And so they do list some things like they're going to streamline how the technology is assessed and how it's approved. And the new legislation will allow for some gene technology to bypass that and in effect be unregulated. And so we might see some applications of gene technology ready for consumer use quite quickly. Okay,
so we're going to see some of these technologies accelerated. Mm-hmm. The sales pitch is what? It's good for the economy?
Yeah, it's good for the economy and everyone else is doing it. Oh, so why shouldn't we?
That's a great reason, you know?
we're being left behind.
Yeah, okay.
Yeah. All of your girlfriends have perms now, so you should do it.
Everyone's wearing leg warmers.
It was a bad idea for me.
So those are the reasons. But we obviously have reason to be cautious with such technology that changes the fundamental building blocks of life.
Yeah.
Can you outline some of the maybe reasons for us to be cautious with this and not just plow ahead and go like, well, everyone's doing it. Overseas, what have they seen where they're actually doing it?
Okay, so the new legislation will allow for gene technologies to be used in healthcare, the environment, and in agriculture. And these have been used elsewhere, and they've also been studied quite rigorously. So we do know about some of the risks that these technologies pose. So there are risks to the altered organism itself. Mm-hmm. That's humans, animals, the plants. That we can make precise edits to the genes using the latest and greatest technology called CRISPR. Yeah. And what that basically does in layman's terms is it targets a specific gene to modify it.
So like I could say, I want my hair to be blonde, and I could go in, get an appointment, and they could change my genes to change my hair to be blonde.
In theory, they could do that.
Yeah.
But one of the problems is, although it's heralded as precise, and it certainly is more precise than things they've done in the past.
This doesn't sound good.
It has been shown to have off-target effects. And an off-target effect is exactly what it sounds like. It's a change that they didn't intend that is near the targeted gene. So it's a non-targeted gene's been changed when they've tried to make a specific change. And so the studies have shown that this has sometimes resulted in the rearrangement of genes. Okay. It's also sometimes caused tumor suppressor genes to be turned off. Okay. And in other times, it's activated cancer-causing genes.
So I could go and get my hair changed, come out with a tumor.
You
Yeah.
might. You just might.
Okay, so I can see why
can be a roll of the
I can
dice.
see why we need to be cautious about just
Yeah.
letting this letting these out of the box. Okay.
But it's not just the organism itself.
Yeah, so you said it's also the environment around it as well. Yeah.
We could potentially make a change, say, to a crop that we consider precise and perfect. Like it's the change we wanted. And then we could put it out into the environment and it could have all kinds of disastrous, unintended effects on the ecosystems around it. And this has happened.
Yeah, I was going to say, it sounds like you have just an example up your sleeve for this one.
Yeah, so in the U.S., the monarch butterfly is now considered endangered because genetically modified crops have basically destroyed its primary food source, which is the milkweed. And so they didn't want to kill off all the monarch butterflies, but that's kind of what happened.
Nice looking butterflies, right?
Yeah. And in Europe, there has been a drastic decline in bird life. They've estimated 550 million birds have died. And one of the contributing causes is the intensive agriculture around GM crops that have been altered to be herbicide resistant. So what that means is you can plant a crop and then it won't be damaged if you put herbicide around
weed killer,
it.
Right?
Yeah, you can kill the weeds around it, but it will still flourish.
Yeah.
But in killing all those weeds around it, you're killing food sources for other animals.
Yes.
And
killing those animals because they're going to starve.
Yeah, and so in Europe, what's happened is that that's killed some of the primary food sources of these birds, and so they've had nothing to eat and they've starved.
Okay, so unintended consequences. How can we mitigate those? What would you like? I guess, what would you like to see if we were going to go forward with some experimentation? Because I guess that one of the arguments is, well, humans have been doing this for a long time, just very slowly, right? We've got new breeds of plants, we've got new species of plants that we've kind of crossbred, and we've been grafting, different types of apples into and created gold kiwi fruit and red kiwi fruit and stuff like that. So this is just that, but much faster. So how would we kind of get at that?
Well, I think it's important to keep in mind something that Professor Jack Heinemann pointed out. He's from Canterbury University, and he basically said it's kind of a semantic sleight of hand to call these things natural, because although it might have the same effect, we might get the product that we want with the characteristics we want. Doing it quickly isn't natural.
Yeah.
And it introduces a lot more opportunity for things to go wrong, especially when you're doing something quickly and when you're doing it in multiple organisms. And so the risk factor multiplies by speeding things up and doing more and more of it. And so
we'd want to slow that down.
We'd want to, well, we could just do it naturally. That's
Yeah.
probably the pace at which it's done safely.
Yes, yeah.
So that's something to keep in mind. He seems to think that we already have the technology that doesn't include gene technology to get the products that we want. And we don't need to do this, that the impetus for doing this really lies elsewhere, because we do have the ability to make the changes that we want to make.
So it's not actually, the sales pitch is not actually accurate. It's that, well, we can already do this stuff without messing with genes.
Without risking catastrophic...
Yeah, causing cancer or decimating our environment.
Yeah.
So why not do that? So why not do that? Do you have is there a compelling reason for us to step into gene modification technology?
Well, there are reasons that some people find compelling.
Yeah.
I don't particularly find them compelling, but the reasons that are given to us is that, we are being left behind, by the cool kids, and we want to be the cool kids, and, maybe we do, but I would prefer to protect our nation and not to make decisions based out of fear of missing out.
Yeah. Okay. So we want to slow it down. We want to maybe not even go there. Let's just take a wait and see approach. Is that kind of what you...
Well, that's what I would like to do. I very much doubt that that's what's going to happen. And so if they are going to go forward with this, I would want them to have more precautions than what they are indicating they're going to have. I don't think we should just let loose any of this technology into New Zealand without careful assessment and approval. But that's me.
Well, Steph, you've given us a lot to think about in terms of this new technology. There's a lot of unforeseen consequences. One line that you had in there is, we don't know what we don't know, right? And I think that's so true. So I hope that people will take these cautions on board, that in the drafting of the legislation, they'll be able to put some of these guardrails, really intense guardrails in place, and we won't see what they've seen overseas. So thanks for being with us today.
Thanks for having me. Greek mythology tells of Pandora, who was given a box containing hope. Upon opening it, she unwittingly released a host of evils into the world, including disease, death, and suffering. Recently, the government unveiled its plan to introduce new gene technology legislation to Parliament by the end of the year. Modeled after Australia's Gene Technology Act 2000, the new legislation will relax current restrictions. It aims to exempt some gene technology from regulation and streamline the approval process for others. The goal? Finally get gene technology out of the lab and into New Zealand. In doing so, we may open a Pandora's box of unintended consequences. Gene technologies allow scientists to alter organisms' genetic makeup. Gene technologies allow scientists to alter organisms' genetic makeup, essentially redesigning biological life forms. CRISPR, a prominent gene editing technique, targets specific genes for modification. While often characterized as precise, the technique can produce unintended DNA changes near the targeted area, known as off-target effects. Off-target effects of gene editing can be severe, including gene rearrangement, activation of cancer-causing genes, deactivation of tumor suppressors, and other mutations. One study found that genetically engineered cows included additional DNA for bacteria, including a gene that confers antibiotic resistance. Gene technology's unintended consequences can be far-reaching. In the US, monarch butterflies are now endangered, partly due to GM crops' impact on milkweed, their primary food source. Similarly, herbicide-tolerant GM plants have intensified chemical agriculture, devastating ecosystems. An estimated 550 million birds across Europe and the UK have perished from loss of food sources. There are also moral concerns about the balance of power between farmers and those who hold patents on genetically modified organisms. Likewise, allowing gene technology to be used in humans risks us falling down the slippery slope to eugenics. It's easier than you think. These are just some of the potential unintended consequences that we know about. Sometimes, adverse outcomes of a new technology go unrecognized for years. Take acetaminophen, also known as paracetamol, as an example. This common over-the-counter drug was first marketed in 1893 and has long been considered one of the safest painkillers around. Recently, however, one meta-study found a consistent association between acetaminophen and adverse neurodevelopmental outcomes in children, such as autism, ADHD, lower IQ, and developmental delays, leading it to recommend limited use during pregnancy. We don't know what we don't know. Gene technology tinkers with life at its basic level. Unsurprisingly, this technology has the potential for significant and far-reaching unintended consequences. Regrets, as Joseph Campbell once warned, our illuminations come too late. While the box of gene technology might hold hope for a better future, it also contains dangers that, once released, won't easily be contained. We must proceed with caution, lest we open our own Pandora's box.